Welcome back to my channel. In this video we will cover physical layer and conclude OSI reference model by the end of this video. In the earlier sections, we saw that segment is created by transport layer, followed by packet and frame in the network and data link layers respectively. Now, the frame is converted into bits and they are now ready to travel through the physical medium. At this stage, everything that has been received from the upper layers are inside bits or electrical signal. Now let's talk about physical mediums. The physical medium includes Ethernet cables, optical fiber, coaxial cable and radio frequency when we are using wireless communication. The Ethernet is widely used technology which has various enhancements over the years. The first Ethernet interface that can operate with maximum speed of 10 megabits per second is Ethernet itself. With revolution of internet and technology, 10 megabits per second was not sufficient to transport text files, images, and videos with different qualities, which led to the developments of fast Ethernet and gigabit Ethernet followed by other high-speed interfaces. We will discuss different Ethernet standards and their supported speeds in the next slide. Now, let's understand communication types, simplex and duplex. As we can see here, the simplex is one-way communication where the receiver can receive data but it is not able to reply back to the source. For example, watching TV, listening to FM radio. In duplex, there is two-way communication. If two devices are able to send and receive data at the same time, that is called full duplex. In half duplex, only one host can send or receive data at the same time. For example, the networking switch from old days, called hub, is a half-duplex device. Also, the wireless radio frequency channel is a half-duplex medium to exchange data. In this slide, we are going to see the difference between two widely used and well-developed physical mediums, UTP cables and optical fiber. The UTP cables are used in a local area network up to 100 meters of distance to connect computer, printer with the LAN switches. The cables have RJ45 connectors that can be plugged into electrical port or Ethernet ports on the end devices and the network switches. You can see the speeds available for each Ethernet standards here. In optical fiber technology, communication is done by using wavelengths of light. And the network switches that use optical fiber requires a module or media converter that can convert electrical signal into lights and vice versa. The small form factor pluggable is a tiny device that is plugged into the fiber ports of a network switch which provides interface for the optical fiber cables. It also has different standards that define their speed and length they can support. The SFP standard can support up to 1 gigabit per second transmission capacity, whereas the SFP Plus standard supports up to 10 gigabits per second. Also, QSFP Plus support up to 40 gigabits per second and QSFP 28 support up to 100 gigabits per second speed. Next, we can see the SFP standards with distance covered by a type of SFP. There are two mostly used modules. The SR or short-range SFPs are used for the devices within same rack or same building up to 300 meters, whereas LR or long-range SFPs are used for the devices to communicate up to 10 kilometers. Also, ER and ZR standards are used if we have a requirement of longer distance like 40 kilometers, 60 kilometers up to 120 kilometers. You may find more details on this in the next slide. An important piece of information here is wavelength. The wavelength is consecutive peaks of a light used for a data transmission which is measured in nanometers. As we can see, based on the SFP standards, the wavelength has differences. Last but not the least, single-mode fiber is usually used in the longer distance whereas the multimode fibers are used within short range. They are typically used with the SR SFP standards. This table shows the specification of both types of cables. In this topic, we saw how OSI model helps us understand about data transmission from one device to another across a network. Each of the 7 layers plays an important role, starting from the application layer all the way to the physical layer which is responsible to send data in the format of bits. The process of extracting a real data by the destination device starts from the bits where it finds frame and packet within the frame and so on. At the end, the destination device will find the application information as the transport layer decapsulates segment and provides upper layer information. It's important to remember that each layer depends on the others to do its job correctly. If one layer doesn't work properly, it can affect the whole process. The OSI reference model is a great tool for troubleshooting network issues because it gives you a clear framework to follow when analyzing where something might have gone wrong. By understanding OSI model, you will have solid foundation for working with networks in real-world scenarios. It can be useful whenever you are setting up a new network or fixing a connection problem followed by configuring devices. In the next video we will cover IP addressing and subnetting topics. I will keep on adding more videos that might be helpful for you to build your networking career. If you like the content, please subscribe and comment for any questions. I will try to answer them as quickly as possible. Thank you for watching and see you in the next video.